Quantitative ability topic is numbers. Numbers is considered to be the basic foundation of mathematics, and in this topic we are going to discuss about divisibility test, successive division and remainder problems. Talking about the divisibility test, how we are going to check the divisibility test for the number 2. कोई भी number 2 से divisible है या नहीं है, ये कैसे check करते हैं? Obviously we focus on the last digit. If the last digit is 0 or even, we say the number is divisible by 2. वही बड़ा number 4 से divisible है कि नहीं, ये कैसे check करेंगे? For 4, we check the last 2 digits. If the last 2 digits are divisible by 4, we say the entire number is divisible by 4. For example, I take a number 75,348. अब ये 5 digit number में अगर आखिरी के 2 digit that is 48 4 से divisible है तो पूरा number 4 से divisible हो जाएगा. Why? Because the same number can be written as 75,300 plus 48. We know 100 is the multiple of 4. Hence, 75300 will be also a multiple of 4. So this is divisible by 4. And 48 is already divisible by 4. Hence, addition of both these will form the resulting number which is divisible by 4. And this is the reason why we check last 2 digits. Okay, what is the test for the number 8? In case of 8, we check the last 3 digits. If the last 3 digits are divisible by 8, the number becomes divisible by 8. For example, I take a number 39,120. इसमें का आखिरी के 3 digit हम check करेंगे. If this last 3 digits are divisible by 8, we say the entire number is divisible by 8. The reason is the same number can be written as 39,000 plus 120. 1000 is a multiple of 8. Hence, 39,000 will be also a multiple of 8. And this is already divisible by 8, 120. Hence, addition of 39,000 and 120, the resulting number 39,120 will be divisible by 8. For 16, we check last 4 digit. For 32, we check last 5 digit and so on. Okay. For 3, what we do? We take the sum of the digits, and if the sum of the digits is divisible by 3, we say the number is divisible by 3. What is the reason? Why we do so? Let's say I take a 3-digit number ABC, where C is in the unit place, B is in the tens place, and A is in the hundreds place. The same number can be written as 100A plus 10B plus C. Further, I can simplify and write as 99A plus 9B plus A plus B plus C. We know that 99 is a multiple of 3. Hence, 99 multiplied by A will be also a multiple of 3. Even 9 is a multiple of 3. Hence, 9 multiplied by B will be also a multiple of 3. So, if this is divisible by 3, this is also divisible by 3. Now, if this sum, so-called A plus B plus C, becomes divisible by 3, we say the entire number becomes divisible by 3. And this is the reason why we take sum of digits for 3. Okay. What is the test for the number 9? For 9 also we do the same thing. We take the sum of the digits, and if the sum of the digits is divisible by 9, we say the number is divisible by 9. Divisibility test for the number 5. If the last digit is 0 or 5, we can say that the number is divisible by 5. Test for the number 6. If a particular number is divisible by both 2 and 3, we can confidently say that it is divisible by 6 as well. Now, what are 2 and 3? They are said to be co-prime factors of 6. Co-prime factors are those factors whose highest common factor is 1. जैसे कि यहाँ पर 2 के फैक्टर्स क्या है? 1 and 2. और 3 के फैक्टर्स क्या है? 1 and 3. उनका highest common factor होता है 1. Hence, we can say that 2 and 3 are co-prime factors of 6. On the similar line, what is the divisibility test for the number 12? अब हम क्या करेंगे? 12 से दो co-prime factors derive out करेंगे, which are 3 and 4. So if a particular number is divisible by both 3 and 4, we can confidently say that it is divisible by 12 as well, as 3 and 4 are co-prime factors of 12. अब देखिए 3 के factors क्या है? 1 and 3. और 4 के factors क्या है? 1, 2 and 4. उनका highest common factor है 1. So 3 and 4 हो गए co-prime factors of 12. Okay. What is the divisibility test for the number 45 by the same method? अब हम 45 से दो co-prime factors derive out करेंगे. Which are those? 5 and 9, because the factors of 5 are 1 and 5 and the factors of 9 and 1, 3 and 9. अब उनका highest common factor हो गया 1. So 5 and 9 becomes the co-prime factors of 45. So if a particular number is divisible by 5 as well as 9, we can confidently say that it is divisible by 45 as well. What is the divisibility test for the number 11? In case of 11, we take the sum of alternate digits, and if these sums are same or differ by a multiple of 11, we say the number is divisible by 11. For example, I take a 5-digit number as 45782. Here I will take the sum of alternate digit, that is 4 plus 7 plus 2, that is equal to 13. And another alternate digit summation I take as 5 plus 8, which is also equal to 13. Now, as both the sums are same, we can say that the given number is divisible by 11. I take another example. Let's take a 4-digit number 3672. Again, I take the sum of alternate digit. 3 plus 7 is 10 and 6 plus 2 is 8. Now, these two sums are not equal and even they don't differ by a multiple of 11. So, the given number is not divisible by 11. For the number 7, what is the test? Unit digit is to be doubled and subtracted from the remaining number. For example, I want to check whether 6545 is divisible by 7 or not. So what I will do, from the given number, I will separate out the unit digit 5 and I will double it, that is 10, and I will subtract from the remaining number 654. So I got 644. Okay. Now from the 644, I will again separate out the unit digit, that is 4. I will double it and I will subtract from the remaining number like this. So 4 is doubled as 8 and subtracted from the remaining number, that is 64. 64 minus 8, we got 56. 56 is a multiple of 7. So we can confidently say that the given number 6545 is also a multiple of 7. So we have discussed about important divisibility test. Now let us work out some questions on divisibility test. Problem number 1. What smallest number must be added to the given number to make it divisible by 9? Now you very well know what is the divisibility test for the number 9. We take sum of the digits. So यहाँ पर भी अपन वही करेंगे. So if we take the sum of the digits, all these digits are added, the summation comes out to be 29. We know 29 is not divisible by 9. So the smallest number that should be added to 29 to make it divisible by 9 is 7. So the sum becomes 36. And जैसे मैंने बताया था, if the sum is divisible by 9, the entire number becomes divisible by 9. So the smallest number that should be added to it is 7. Problem 2. What number must be subtracted from the given number so that it is divisible by 11? You can pause this video and try the question on the paper, and once you have solved it, you can again play the video to look for the solution. Okay, this is the given number. Here we take the sum of alternate digits. So 8 plus 3 plus 5 is 16. And if we take the sum of another alternate digits, that is 6 plus 7, that is equal to 13. Now these two sums are not equal. The number will be only divisible by 11 if the two sums are equal. So for that we need to subtract 3 from the summation of 16. So 5 में से मुझे 3 minus करना पड़ेगा. So उससे क्या हो जाएगा कि ये जो sum आ रहा है 16 वो भी 3 से less हो जाएगा. And then this also becomes 13 as well as this is also 13. And the number becomes divisible by 11. So the question is, what number must be subtracted? So 3 should be subtracted. Option B is a right answer. Problem 3. Find the smallest possible value of x which will make the number 6x743y divisible by 24. First of all, we should think about what is the divisibility test for the number 24. For that, we should take out two co-prime factors from 24. The co-prime factors of 24 are 8 and 3. Now what is the divisibility test for the number 8? We check the last 3 digits. And what is the divisibility test for the number 3? We take sum of the digits. Now in the given number, we need to identify the last 3 digits that should be divisible by 8. उसके लिए y क्या होना चाहिए? The only possible value of y to make the last 3 digit divisible by 8 is 2. Because 432 is divisible by 8. So y can be 2. So we have decided what is y and we have done for the number 8. Now we will check for 3. For 3 we should take the sum of the digits. So सारे digits का हम अगर addition कर ले for checking the divisibility test of 3, it will come out to be 22 plus x. 6 plus 7 plus 4 plus 3 plus 2 plus x, that is 22 plus x. And this should be divisible by 3. For that, what can be the possible value of x? The only possible value of x will be either 2 or 5 or 8. Because if I take x is equal to 2, it will be 24, which is a multiple of 3. If I take x is equal to 5, it will be 27, which is again a multiple of 3. If I take x is equal to 8, it will be 30, which is also a multiple of 3. Now in the question it is asked, find the smallest possible value of x. So the smallest possible value of x is 2. Option C is a right answer. Problem 4. A 8-digit number is given to you and it is said that it is divisible by 72. Find the maximum value of p. Okay. Now, what is the divisibility test for the number 72? हमको 72 से दो co-prime factors derivate करना है. Which are those? Obviously 8 and 9. What is the divisibility test for the number 8? The last 3 digits must be divisible by 8. And what is the test for the number 9? Sum of the digits must be divisible by 9. Okay. Now this is the given number to you. For the last 3 digits, we need to check, that is 24q. To make the number divisible by 8, what should be the possible value of q? The possible value of q can be either 0 or even 8. Because 240 is also divisible by 8 as well as 248 is also divisible by 8. So दो possibilities आ रही है यहाँ पर. Okay. Now we will check for the number 9. उसके लिए हमको sum of the digits लेना पड़ेगा. So अगर हम पहले नंबर के sum of the digits लेते हैं, that comes out to be 14 plus p. Now what can be the possible value of p to make the number divisible by 9? The possible value of p can be only 4. और हम दूसरे नंबर में अगर sum of the digits लेते हैं, that sum comes out to be 22 plus p. Because यहाँ पर 8 है unit digit में. So that comes out to be 22 plus p. To make it divisible by 9, what can be the possible value of p? The only possible value of p will be 5. Okay. Now it is asked in the question, find the maximum value of p. So the maximum value of p can be 5 to make the number divisible by 72. Now let us talk about equation of division. When we divide a dividend with certain divisor, we get a quotient and certain remainder. What is the relation between them? Dividend is equal to divisor into quotient plus remainder. On this basis, we will try out some questions now. Problem number 5. On dividing a number by 65, we get 42 as a remainder. On dividing the same number by 13, what will be the remainder? So यहाँ पर जैसे बोला है, एक नंबर है जिसको हम 65 से अगर डिवाइड करें तो एक क्वोशंट मिलता है, लेट अस से q, और 42 रिमाइंडर आता है. So how we can write the number n? It is equal to divisor into quotient plus remainder. So n can be written as 65 into q plus 42. Now the question is, if we divide the same number by 13, what will be the remainder? So if we divide the number by 13, the first term, that is 65 into q, will be divisible by 13 because 65 is a multiple of 13. So 65 multiplied by something will be also a multiple of 13. So पहला term 13 से divisible है. Talking about the second term 42, it's not divisible by 13. So if we divide 42 with 13, we get remainder as 3. So if we divide the number n with 13, the remainder will be obviously 3. Option A is a correct answer. Problem 6. A number n when divided by 11 leaves 7 as a remainder. When n square is divided by 11, the remainder is what? So there is a number n, and if I divide it by 11, the remainder I obtain as 7, and let us say the quotient is q. So how the number n can be written? It is divisor into quotient plus remainder. So n is equal to 11 into q plus 7. Now the question is, when n square is divided by 11, what is the remainder? So I will take square of n. So it is 11 cube plus 7 whole square, which comes out to be 121 q square plus 2 into 11 cube into 7 plus 49. That is a square plus twice ab plus b square. अब इस नंबर को अगर हम 11 से डिवाइड करें तो व्हाट इज द रिमाइंडर? सो ये आई डिवाइडेड बाय 11. The first term 121 is a multiple of 11. So 121 into q square will be also a multiple of 11. So पहला टर्म 11 से डिवाइड हो जाएगा. दूसरे टर्म में ऑलरेडी यहां 11 है, सो दूसरा टर्म भी 11 से डिवाइड हो जाएगा. Talking about the third term 49, it's not divisible by 11, and if I divide 49 with 11, the remainder obtained is 5. So if n square is divided by 11, the remainder obtained is 5. Option C is a right answer. Problem 7. A two-digit number n when successively divided by 4, 3 and 2 gives the remainder as 1, 2 and 1 respectively. The largest possible value of n will be what? Now first of all, we will take a number n as mentioned here, and if we divide it by a divisor 4, the remainder obtained is 1. So I divide n with 4, the remainder obtained is 1, and let us say the quotient is a. In successive division what we do, जो हमको पहला क्वोशंट मिलता है उसको हम दूसरे डिवाइजर से डिवाइड करते हैं. सो a को हम अब 3 से डिवाइड करेंगे, जिससे हमको रिमाइंडर 2 मिलेगा as mentioned here. So I am dividing a with 3, I am getting the remainder as 2. Let us say the quotient is b. अभी ये जो क्वोशंट मिला दूसरे केस में, इसको हम थर्ड डिवाइजर 2 से डिवाइड करेंगे फिर से, जिससे हमको रिमाइंडर 1 मिलेगा. So if I divide b with 2, I am getting the remainder as 1, and let us say the quotient is c. So how the number n can be found out? It can be found as divisor into quotient plus remainder. So n I will write as 4 into a plus 1. Now what is a? A is equal to 3 into b plus 2. So I will replace a as 3 into b plus 2. Fine. Now what is b? B is equal to 2 into c plus 1 as divisor into quotient plus remainder. So I will replace b as 2 into c plus 1. Now if we simplify this particular equation, what we will obtain is 24c plus 21. Now we need to decide what can be the value of c to get the largest possible value of n. And n is said to be a 2-digit number. So largest 2-digit number हमको पता लगाना है. So in this particular number, n is equal to 24c plus 21. If I take c is equal to 0, suppose, in that case n will be equal to 21. If I take c is equal to 1, n will be equal to 24 plus 21, that is 45. If I take c is equal to 2, suppose, n will be equal to 24 into 2, that is 48 plus 21, which is equal to 69. And if I take n is equal to 3, sorry, c is equal to 3, n will be equal to 93. So 93 is the largest possible value of n, a 2-digit number. Hence option C will be the right answer. Finding remainder. I will take one simple example here. Let us say I take a number 720 and I divide it by 7. If I divide it by 7, what remainder I will obtain here? As you see, the remainder obtained will be 6. Now suppose if I factorize the number 720 as a product of 3 numbers, say 10 into 9 into 8. And if I divide these individual factors 10, 9 and 8 with 7, what remainder we expect here? If I divide 10 with 7, the remainder obtained is 3. Similarly, if I divide 9 with 7, the remainder obtained is 2. And if I divide 8 with 7, the remainder obtained is 1. Now, if I take the product of remainders that are obtained by dividing each factor, it will be 3 into 2 into 1, which is equal to 6. So the same remainder I get here, what I got by dividing the number 720 with 7. From this, we can conclude that the remainder obtained by dividing a number with a divisor is same as the product of remainders obtained by dividing its factor with the same divisor. And applying this concept in the questions, we can determine what remainder will be there at the end. Problem number 8. Find the remainder when 3 to the power of 131 is divided by 8. Now, suppose if I divide the number 3 with 8, what remainder we expect? Obviously, the remainder will be 3 itself. But suppose if I square the number 3 square, and if I divide it by 8, means 9 if I divide by 8, what remainder do we expect? The remainder will be 1 here. Now this is something a useful result what we got, and with this we can simplify this question like this. So 3 to the power of 131, I want to divide it by 8, and I will make the clusters of 3 square like this. So there will be total 65 such clusters of 3 square, because 2 into 65 is 130 and 1 3 will be written separately here. So this will be equal to 9 into 9 into 9, 65 times, and one more 3 is there, everything divided by 8. Now if I divide every 9 with 8, what remainder we get? 1. So remainder will be 1 obtained for 65 times, and if I divide this 3 with 8, the remainder will be 3. The product of these remainders will be 3. Hence, if 3 to the power of 131 is divided by 8, the final remainder obtained is 3. Option C is a right answer. Problem number 9. Find the remainder when 7 to the power of 70 is divided by 4. Now first of all, we need to think, if I divide 7 with 4, what is the remainder? If I divide 7 with 4, the remainder obtained will be obviously 3, which won't give a useful result to simplify a question. Now suppose if I square it, if I do 7 square, and if I divide it by 4, that is 49 divided by 4, what is the remainder obtained? The remainder obtained will be 1. Now this is giving something useful result to simplify this question. So 7 to the power of 70 divided by 4. Here also I will make the clusters of 7 square. So there will be 35 such clusters of 7 square. So that is equal to 49 into 49 for 35 times. Everything divided by 8. If I divide every 49 with 8, the remainder obtained will be 1. So I will get 1 into 1 for 35 times. The product of all this remainder obtained is 1. So the final remainder when I divide 7 to the power of 70 with 4 will be equal to 1. Problem number 10. Find the remainder when 2 to the power of 55 is divided by 9. By the same procedure, we can simplify this question. First of all, we take the number 2, and if we divide it by 9, what is the remainder obtained? The remainder will be 2 itself. If I square it, suppose 2 square, and if I divide it by 9, the remainder obtained will be 4. If I suppose cube it, 2 cube divided by 9, the remainder obtained will be 8. If I take fourth power of 2, that is 2 to the power of 4 divided by 9, means 16 divided by 9, if I do, the remainder obtained will be 7. We are not getting any useful result right now. So let us say we take the power of 5, 2 to the power of 5, that is 32 divided by 9. What is the remainder? 32 divided by 9, the remainder obtained is 5. So next power we will take, that is 2 to the power of 6, that is 64 divided by 9. If we do, the remainder obtained is 1. And yes, this is something useful to us, which will simplify our problem. So here we will make the clusters of 2 to the power of 6. So if I want to divide 2 to the power of 55 by 9, I will make the clusters of 2 to the power of 6 like this. There will be 9 such clusters, as 9 into 6 is 54, and 1, 2 will be written separately. So this can be further simplified as 64 into 64 for 9 times, and one more 2 will come. Everything divided by 9. Now if I divide every 64 with 9, I get the remainder as 1. So the remainder obtained will be 1, 1, 1 for 9 times, and the last 2, if divided by 9, the remainder obtained is 2. The product of all such remainders is 2. Hence, when 2 to the power of 55 is divided by 9, the remainder obtained is 2. Option B is a right answer. In part 2 video of numbers, we will discuss about the concept of LCM and HCF, LCM and HCF of fractions, different models of LCM and HCF, and some important problems related to LCM and HCF. In part 3 video of numbers, we will discuss about the problems of factorization, concept of power cycle, and largest power in the factorial. So that's all with this particular part of numbers, part 1. Thank you for watching this video.